are eating the wrong fat.
Ah, the wrong fat. Good. The wrong fat. Yes, of course, Lou. Of course, we're eating the wrong fat. More cholesterol misinformation online from doctors who think they know what they're talking about.
Hi friends, your cholesterol test might look normal and still miss the real danger. Today,
okay, so now we're already off to a great start here. So your cholesterol test may look normal. Who cares? Who cares if it looks normal? Who cares if it looks abnormal? What are normative ranges? I mean, really, let's think about that. What are normative ranges for any blood test at all? Normative ranges, I often say very simplistically, because it's true, that they are reflective of the normal population. Except that's not even exactly correct. So it's true, but it's also not. Why do I say that? Because how did they collect those normative values? Well, they collected data from individual clinics around the country. In this case, the United States. Usually other countries will base it off of the United States demographics. India is an example of this. But some countries don't. They base it off of their populations. So the UK has their own, but their results are pretty much the same. And basically what they do is they aggregate all of that into an interval range for each individual vitamin, nutrient, or in this case, lipoproteins and cholesterol, a high molecular weight alcohol and steroid molecule. And then they say, oh, well, that's normative. Well, that's a little interesting, isn't it? Because is that reflective of every single person on the face of well, not on the face of the earth, yes, but also even in that country? No, granted, it's not really possible to grab all that data, but it doesn't make it any less of a limitation. Okay, so it's a limitation that we should be aware of, not to say that you should just throw that out the window based on that logic alone. That's inane, right? But here's the other problem. Of those people, is that really the best thing to be referring to whenever you're trying to extrapolate sort of baselines and normal ranges for an entire population, even in that country? Again, you might say, well, yeah, because you can't collect everyone's data. Yeah, but that's not the point. There is massive response bias. Why do I say that? Because how many healthy people that experience no symptoms and have no disease processes present, how many of those people go to the doctor? How many of those people actually go to those clinics to have their data included in the data set? I mean, there's a few, because some people, they religiously, adhere to their yearly checkup kind of thing with their general care practitioner. But I don't. I would venture to guess that not many people do. And so now what we're talking about is actually a normative range that, once again, is necessarily not representative of every single person in the country in which it was conducted or arrived at and constructed, is really what I should say. But also it's highly skewed with response bias, because it's based on people that go to the doctor's office, perhaps even regularly. So those are the first few issues that I want to get out of the way. So who cares whether you're in normal ranges? But second of all, even if those things were not true, look around you at what normal is. Normal is diseased. It is debilitation. It is autoimmune issues. It is diabetes. It is obesity. It is, I mean, name a condition, heart disease. Can't forget that one with the topic of today's video. So do you want to be normal? Do you want to fit within the normal ranges? Is it true that even if you're in normal ranges, can you still exhibit pathology? Is it true that even if you're outside of those ranges, is it true that you don't have to present with pathologies at all? So anyway, even if you're going to try and use it as a reference range, it's really, really, really weak. Really weak. So we're 5 seconds into the video, and we're done with that. You know what? Just for fun, let's restart those 5 seconds just to really get a very, very good idea of what she's about to say here.
hi friends, your cholesterol test might look normal and still miss the real danger. Today,
Right. Well, the real danger when it comes to heart disease, which is the actual topic of today's video, your video, ma'am, is uh, is damage to the arteries, which cholesterol doesn't cause, unless you do some experiment or something where you just you introduce a massive amount all at once of cholesterol into the arteries, then perhaps, but that literally goes for every molecule on the face of the planet, including water, by the way. So that's not a good argument. And by the way, I'm not just saying that just to be stupid and pedantic and captious is really the word to use. Um, it's actually because the true origin of the lipid heart hypothesis actually originated in the 1890s with a Russian scientist by the name of Nikolai N. Anichkov, whereby he actually force-fed rabbits pure cholesterol and saw that they developed atherosclerotic plaque. Um, you see, rabbits, first of all, are herbivores. But second of all, even if they weren't, you force-fed them pure cholesterol, and that's one step away from basically introducing it into their arteries or something at massive concentrations. So that's why I bring that up. So anyway, continue.
Top lipidologists are measuring blood markers your standard labs don't catch. Now, why?
Well, so the top lipidologists. So why are we referring to them when it comes to heart disease risk? Again, I mean, we'll get into the hemodynamics, the actual etiology of heart disease in a minute, but why are we even looking at that? Why are we even looking at what they say? Not to mention, it's just another appeal to authority, because could they be wrong? Yes. And then appeal to consensus, really, because appeal to consensus is a subset of the appeal to authority. It's the same thing. It's just a different version of it, where instead of looking at one authority, you're looking at a consensus panel of multiple authorities with some dissenting voices. Sometimes not, though. And then that puts into question the conflict of interest as well. So anyway, okay.
Should you care? Because getting cholesterol wrong may affect how you think and move as you age.
Right. So it also may not, because you use the word may there. It also may not. You can basically use the word may to describe everything. In fact, really good experiment, really good idea that I recommend personally that you do, in my opinion, is every single time that you see a headline that says, "Oh, doing this may increase your risk of blank by blank percent," or may decrease your risk of blank. Also put just replace the word may with may not, and then read those headlines again. Yeah. So anyway, okay. So she's got an Asian name. Um, you can see it right there. So I'm gonna call her Lou because I don't want to butcher the name. I apologize deeply for my Americanness, my lack of multiculturalism, and I mean, I'm being a little facetious, but it does have its downsides, of course. So, all right, let's continue. Lou, MD, MD, by the way, medical doctor. Good. So, in terms of what she received training in, not nutrition, which is probably a good thing, but it's pointing to the contradiction of believing that people it's pointing to the contradiction of people that claim that they have the authority to speak on nutrition because they're an MD. That's the problem. Okay, so just she hasn't said that yet, but just in case to sort of anticipate that claim, whether it's made explicitly or implicitly, we're going to get that out of the way first. So no, and also science. She doesn't have any training. If her only training was MD, I mean, maybe she's multiple other things, but usually those are listed. She doesn't have any training in research and actually how to interpret science, statistics specifically, which is really the foundation of all science, isn't it? Numbers, math. So just things to keep in mind. It doesn't mean that she doesn't know these things, but it means that she didn't receive training in these things. So if she wants to, once again, either implicitly or explicitly point to her position or her, sort of credence as an ND as evidence of her authority to speak on science and or nutrition, that is flawed. That is fallacious. All right.
Even medical experts can't agree on whether high or low is better. Now, some
Well, your cholesterol levels and your lipoproteins and any subtraction of lipoproteins, et cetera, are all determined in terms of their levels by your genes and nothing else. Now, that's not to say that therefore no level is indicative of a problem. For example, if you're producing glucose endogenously, so in your body via your liver, your kidneys, et cetera, because you're not eating it, um, really that's kind of misleading because that implies that you only do that when you're not eating carbohydrates. You're always producing glucose to some degree, but if you're depending solely on glucose production from your body because you're not eating it, like any at all, you can still, depending on circumstances, exhibit a level of glucose that is too high and is causing you, therefore, damage to your arteries, damage to, I mean, basically every cell of the body that is experiencing too high of a concentration of glucose is encountering that level, despite the fact that that level was controlled by your genes, given the environment in which they were placed at the time. So it's not to say that, but that's one piece of the puzzle when it comes to what the cholesterol level is. I mean, it's one piece of the puzzle in terms of sort of navigating the treatment process if cholesterol were actually causal in heart disease. Would it actually be to just manipulate the genes, or would it be to, engage in more holistic behavior and more organic, um, traditional behaviors? So that's one part of the picture. So in terms of, whether high cholesterol, low cholesterol is better, we need to get that out of the way first. But second of all, to actually really address this claim, this is a waste of time. This is effectively, in a way, it's a red herring. It's really just a distraction away from what the actual problem is. Why do I say that? Why do I say that? Because cholesterol is not the cause of heart disease. Typically, the example that I use here is actually with respect to a fire pyramid. Usually, you'll see a pyramid, and it's every point on that triangle it represents an ingredient required for a fire to actually manifest or exist. One corner is a fuel source like wood, classic. Okay. The other is heat, and the other is oxygen. So, what happens when you remove one of those points? Well, if you remove any one of those points, you will not have the fire. Now, in this situation, it's a little different because instead of a triangle, we're really kind of looking at a line, in terms of the relevant factors here. So, you've got cholesterol, and then you've got damage to arteries. Now, here's the problem. Cholesterol is necessarily, and by problem, really what I mean is here are the details. There's not a problem here. Let me just continue explaining. Cholesterol is involved in the heart disease process necessarily. It has to be, actually. You will always find cholesterol in plaques, always, typically in the form of LDL. You'll also find some oxidized LDL as well. And that's a key point that we'll get to later on. So you'll find all of these. You'll find them in these soft plaques, particularly the soft plaques. In the hard plaques, you've got 1 plus or minus 1% of it consisting of cholesterol, foam cells, and all that stuff because it's hardened and whatever. But the more unstable plaques are actually the soft plaques. They're the ones that rupture. They become unstable and rupture, and then they cause thrombi, and then they cause a blood clot, and that's what actually causes your first myocardial infarction, heart attack. So, or stroke, I mean, depending on where it's lodged, right? But anyway, the problem is believing, therefore, well, then we need to get rid of the cholesterol there because, well, that's just like saying that at every single fire, if we're going to use the fire analogy still, well, there's always going to be firefighters at the site of the fire. So therefore, in order to get rid of the problem, we get rid of the firefighters. It's not the best analogy, and I'll tell you why it's not the best analogy, because if you remove the firefighters, the fire still exists. And I mean, I guess actually, in a way, that makes it a good analogy because of what the other factor is, which is the primary problem, which is damage to arteries. The cholesterol won't end up there if there is not damage to the arteries. Okay, you'll have some cholesterol there because there's always continuous damage to arteries to some extent. You always suffer from free radical damage. You always suffer to some extent from glycation damage, by the way. That's actually a natural thing. It's why we will never attain an HbA1c value of 0% ever in our lifetimes. We still experience damage from oxygen, like I just said, free radicals, because we have to breathe oxygen, and oxygen creates nasty byproducts. Very interesting history as to how organisms actually started to use oxygen themselves, which was originally just a waste product from plants through their cellular respiration process. So anyway, so you have two choices. You can either get rid of the fire and let the firemen do what they like and do what they are going to do when the fire's not there, or you can get rid of the firemen and still have the fire there. Either way, you'll still have, it seems, a reduction of plaque. It does seem so, absolutely. Um, but the problem is thinking that that is the criterion of overall health is heart disease status. Because what else do statin medications do? And by the way, it depends on what kind of cholesterol lowering medications you're taking, like statins, bile salt sequestrants, PCSK9 inhibitors, whatever it may be. You got HMG CoA reductase inhibitors as well. Those are, I think, the primary ones sold, but I could be wrong. So it really depends. And so, well, the actual solution is staring you in the face as to what you ought to be doing. It is staring you in the face. It is healing the injury. It's basically a callus internally. It's almost like a cut internally. You've got, when you have a cut on the exterior of your skin, it'll bleed and then it oftentimes scabs over. The scabbing is like the um, the plaque buildup. Now it's a little different, obviously, because every analogy is a little different from the actual example, but it's the best analogy that I can think of at the moment. I guess actually the best analogy would be the callus analogy, because if there's abrasions to the system, over and over and over again, your skin starts to get thicker and thicker and thicker, and then eventually they can regress back down whenever the damage sort of ceases. So we'll get more into this as well, like where plaque actually develops, more proof that cholesterol isn't actually the cause, sole cause of heart disease. It is a factor, it does have a role to play, and how cholesterol itself plays the contributing factor to perpetuating heart disease depending on circumstances whenever we get to it, because we've already been talking for quite a long time. So let's continue.
Studies link it to sharper brains and stronger legs.
Well, linking something to something else is merely an association, which immediately puts into question the strength of the association, the relative, not in relative terms, but actually in absolute terms. If you're comparing two cohorts together in a longitudinal fashion, it puts into question the error around the signal as well, um, in terms of the averages that were collected or the medians, depending on the skew of your random variable, puts many questions into play. It even, if you want to even just throw this on there, statistical significance as well, which doesn't necessarily confer practical significance, but I mean, it's one step closer, I suppose. Um, yeah.
Others to heart attacks. And the American Heart Association, they keep changing their minds too, again and again, because they too have been wrong. So here's the truth most people never hear.
They've not only been wrong, but they've actually engaged in fraud over time. I want to be very careful. A corporation itself is run by people. We need to think of corporations as a group of people. And so just because something happened decades ago doesn't mean that now they're the exact same as they used to be. Um, People have different opinions on a country depending on who's in power. It's not the country itself that's the problem. It's the people that are in power. So it's individuals. So just because they engaged in that fraud before doesn't mean that now they're just as bad as they used to be. It also doesn't mean that they aren't as bad as they used to be, or potentially worse. But I just want to throw that out there. So we need to be careful in saying things like that. But it is true that historically they have been wrong, and not only been wrong, but actually were involved in fraudulent, manipulative promulgation of information, and in this case, hence why I'm saying this, misinformation, um, which means that they could be wrong again. And it seems that they are very routinely wrong, and that's not exclusive to the American Heart Association. That is a consequence of people engaging in what they believe to be science, but is what is actually scientism. It is a worship of science And again, not science, but it is a worship of, it's a prideful act nowadays. It's a reversion, it's a perversion of what science is supposed to be, which is humble curiosity and play in the universe in order to appreciate the universe for what it is, not a way of sort of trying to reinforce your preconceived notions about the universe by perverting, once again, the scientific method and arriving at conclusions, not through actually arriving at them, but by choosing the conclusions first and constructing a pathway that seems to make sense as to how you arrived at that, that may or may not actually make sense. Usually it doesn't, if these people, once again, are the people I'm saying arrived at these conclusions, which are oftentimes liars and people that are in it for money and personal gain in some form or another. So it's not science. What we're seeing today, it is scientism. Through people that are overall not even prideful in many cases, but are exhibiting pride whether they realize it or not, because of what they've been taught is appropriate. I would actually venture to guess that Andrew Huberman is one of these people. A reliance, an emphasis on statistics, which as a science itself is fine, whatever. The reporting of it and the collection of it is often the problem, particularly the reporting of it, with using language that necessarily implies causality when you can't inform upon that with statistics, descriptive or inferential, because it makes no claims about causality via epistemological limitations.
LP little a is bad. You should have.
Okay, so yeah, so she decided to say at the very end, oh, here's the truth. Here's the truth that they're not telling you. Right. Okay. So high LP little a is bad. There's no evidence to support that claim whatsoever. What's bad is what is effectively what we're talking about when we mean something is bad, is something that is contraindicated. Buy now. Link in the description below for second edition, paperback, hardcover, ebook, and self-narrated audiobook editions. If you have not bought this book already, which I believe that you absolutely should. Anyway, we're talking about what is contraindicated. Not advised as a course of treatment or procedure, but really, that just makes it an opinion, doesn't it? Really, contraindication definitionally is the diametric opposite, is the opposite of indicated. What is indicated? Which is basically inferred from the prevailing scientific theory, the most prevailing scientific theory, which is still a theory, which is the Darwinian principles of evolution, evolutionary biology. So what are genes most evolved to genotypically withstand? Okay, so what would that be? Continuous damage to our arteries from contraindicated introductions into the system at large, which is primarily in the form of food, or what we consider colloquially food as a whole, as a general population, broadly. The reason for that is because food has the most intimate influence over our genes than really any other stimulus. Why wouldn't it? So there's multiple other factors, and I'm not pretending otherwise, but hypertension seems to be the most prominent one. And hypertension seems to primarily be caused by phenomena like insulin resistance. Not to say that insulin resistance is a problem, because insulin resistance is not a pathology on its own. It is what the genes are designed to withstand. It is caused by, really, in terms of the what's considered pathological insulin resistance, not physiological, pathological. So the ones associated with obesity and all that stuff. Carbohydrate consumption in excess. What is excess? Well, it's beyond what our genes most evolved to genotypically withstand, which is really beyond 0 grams a day. Because what is the requirement for exogenous carbohydrates in the human diet? Dietary carbohydrates? Throughout any stage in anyone's life, including infancy, after weaning from breast milk, I suppose. 0. Many inferences to support that claim, but we'll get to that later. It's not high LP little a. And again, high according to whom, on the basis of what? Seriously.
Have this checked. This is genetic. If you have a normal number.
Okay, so if it's genetic, then it's encoded for by the genes. Those genes having evolved for billions of years, really, from every inference we have. But for millions of years in our species, if you include proto-humans that preceded our current speciation, that being Homo sapiens sapien, if it's encoded for by the genes, then saying that it should be those genes should be functioning differently is by definition misanthropic. It is antithetical to what the body is designed to do. Like, the only time that is different is if you have a genetically abnormal person that, well, is exhibiting genetic phenomena that is actively killing them, which I suppose is what you're basically saying here. That's why we have gene therapy. Sickle cell anemia, actually, is an example of one of these phenomena. One of these phenomenon, actually. Well, no. One of these phenomena, yes. It served a purpose, which is why their genes are doing it. So it's not like the genes are anti-human. Okay, it's doing it to protect itself through positive and negative selection pressures. But that stimulus, given the fact that we live in a modern world, is no longer relevant. It's no longer necessary. Unless they still live in a place where there's very high malaria rates. So anyway, there's nuance to everything. I'm not pretending otherwise, but as a very, very broad general rule, 99% of the time, let the genes do what the hell they're supposed to do. Seriously.
You won't need this repeated. High ApoB is bad.
No, it isn't. Again, using these vapid value judgment statements that are predicated on no science whatsoever of any integrity, and really no science at all because there's no citations here. You're just throwing out a bunch of propagandistic nonsense. High ApoB is bad. ApoB or ApoB is a tag that is found on LDL and other lipoproteins, but LDL specifically in this context, relevant to this context. It's a tag on it that allows for other receptors to pick up on it so that the cholesterol molecules inside the lipoprotein can unload themselves, relinquish themselves into a cell for repair. And that's the key, repair, because cholesterol is involved in the repair process of every single cell membrane of every single one of the trillions of cells in your body.
It carries cholesterol, and it dramatically changes with your diet. Now,
all right, so you clearly have no idea what you're talking about because ApoB does not carry cholesterol at all. Lipoproteins carry cholesterol through the bloodstream because lipoproteins are actually water soluble and cholesterol isn't because it's a lipid. And if you didn't have the lipoproteins, the cholesterol would form an embolism in your blood and you would die. The ApoB is a tag on these lipoproteins and nothing else. It does not carry cholesterol. Not to mention, what? Oh, well, these carry cholesterol. Uh-huh. So does HDL and literally every lipoprotein in the body. What are you talking about? I mean, this actually goes against what I think she believes, which is, well, HDL good, LDL bad. Well, they both carry cholesterol. So what is your point? Oh, yes, anything that carries cholesterol is bad. You know, that molecule that makes up 40 to 50% of every single one of the cell membranes of your cells, makes up the myelin sheathing on neurons, is an essential, fundamental component of your sex hormones. Yeah, that evil molecule, you know? Yeah. Wow.
overeating any calories will get you high ApoB levels.
All right, so I'm really, really not a fan of you, Lou. You are extremely offensive, more than the average, I would suspect, that I encounter. You really are. Overeating, define that. Usually, I'll define it for you, for simplicity's sake, for the sake of brevity, and as well as just, well, yeah, sake of brevity. Overeating is eating beyond what is required for your body. Okay? Beyond what is indicated for you to be consuming according to your ancestral lineage and according to really your overall genome throughout history, throughout the most recent amount of time, sufficient enough to cause full genotypic adaptations to said behavior, which is usually determined by your satiety signaling. If you are, well, of a normally expressed phenotype, I suppose, certain phenotypes nowadays, because of our modern context, can interfere with that. So that's why there's nuance there too. But generally, for the same reason that we say that humans have 5 fingers and 5 toes, despite the fact that some people have 6 and some people have 4. Okay, again, sake of brevity and efficiency. So that's what we mean by overeating. Okay, fine. And then what's this word on the what's this word on the screen here? Calories. Calories, right? Okay, okay. So last I checked, calories really refer to kilocalories, kcal. And kilocalories are the amount of heat required to raise the temperature of 1 kilogram of water around a closed thermodynamic system, also known as a bomb calorimeter, by 1 degree Celsius. It is a measure of kinetic activity, or the movement of molecules in that water, that movement being caused by photons of a certain wavelength interacting with the surrounding water after being released from the rapid combustion of the food in the bomb calorimeter via a massive electrical current. And again, last I checked, human beings don't do that with food. Human beings are open thermodynamic systems, which means that we allow for the flow of energy in and out of the system, as well as the flow of mass in and out of the system. What we do is we consume mass in the forms of carbohydrates, proteins, fats, and alcohol, chemically interact those substances under control of molecular oxygen. They react in such a way so as to alter the positioning of the chemical bonds. And since those reactions are exothermic, some photons of light, some heat units, some calories are, yes, indeed released, most of which, about 70%, is to entropy, which creates our body heat. So we do release calories regularly. And the rest of which is encapsulated in the form of, chemical potential energy, I suppose. But really, well, yes, through substrate level phosphorylation in between ADP and PI to form ATP, the cellular energy currency, or the molecular energy storage form of the body. So you might say, okay, well, Eddie, that was just a bunch of, again, captious language. Um, you're being pedantic for no reason. To which I say, no, I'm not. Because as much as it's true then that calories are therefore, as a result of that, used as a proxy measure of mass changes, even if they don't directly change the mass balance of the body, because they don't weigh anything, because they're not units of mass, they're units of energy, and energy doesn't weigh anything. As much as that's true, let's start from the beginning. Calorie numbers on food labels are out by 20% in either direction, because calories cannot be directly measured. They can only be estimated, because energy cannot be directly measured. So every single number that you see on a food label for calories, it's plus or minus 20% of that value. That's the actual range of calories that it could have. Okay, so that's the first error. Secondly, how much of those calories are you actually absorbing? Every single phenomenon in the body involves diminishing returns. Trails off. Okay? And that varies depending on the molecule as well. So there's a problem there. How much of it are you actually absorbing? Fiber is involved, or is included in the calorie number on food labels. Fiber is. Do you absorb fiber? What if you have gotten enough protein for your requirements for that day? Do you absorb the protein then? Do we excrete mass in the forms of urine and fecal matter and sweat and tears? Again, it all just has to do with the fact that we're open systems, not closed systems. So the first law of thermodynamics is applicable to an open system, but not sufficiently applicable. It's one part of the picture. You then have to include the law of conservation of mass, which, by the way, is not a law, but as a practical law, sure. It's not technically a law, it's a practical law. You have to include that into the equation, and they've done so, and it's a very, very impractical equation and not one that you can really follow. So, no. And also, finally, to address the very thing that she said, overeating calories. We already covered that, which you can't do because you can't consume a calorie. Overeating calories will raise your ApoB level. No. So now you've just made a faulty generalization to an entire population of people based on very small samples of certain studies, so also Texas sharpshooter fallacy, cherry picking, certain studies that seem to suggest with very, very inadequate, insufficient, noisy data and associations and weak associations of that, that overeating calories as reported is associated with an increase in ApoB levels beyond the baseline observed at the study, mean plus or minus standard deviation, or again, median plus or minus MAD if the data was skewed. Here's what I have to say about that. Even if overeating calories, if that were something that you could do, even if overeating calories was causally related to an increase in ApoB, let's just say that for the sake of the argument, is it the only thing that is associated with that? Do your ApoB levels fluctuate up and down? Do your LDL levels fluctuate up and down depending on what you're doing? People think far too linearly nowadays. X goes to Y goes to Z, when everything should really be conceptualized as a spider web net, with each point on that net, each intersection, representing a variable. Yeah. And every single line, every single part of the web being bidirectional. So yeah, I think we're done here. This is just a bunch of arrogant nonsense. But okay, let's continue.
And being overweight.
No, being overweight is associated with high ApoB, perhaps in certain studies, which cannot be extrapolated to the people not studied. This is the flaw of inferential statistics. Inferential statistics is inappropriate to apply to human nutrition science when your cases are completely, fundamentally different from each other in myriad ways. But even in descriptive statistics, you can make opinions about it being applicable to other people, like, oh, perhaps this could happen to you then. But you can't do that still factually. You can't do that. Not responsible. What was the statistical power of these studies? Were these based on randomized control trials? Were these based on longitudinal studies? Do you know how to interpret these? I'm sure you don't. I'm sure that you don't. Well, I'm not sure technically, but I'm sure that you don't.
Specific foods are even worse.
No, in your opinion. So they're associated weakly with certain hard health outcomes that you perceive to be negative, that you deem to be negative, when they are, or at least they haven't been proven to be.
High triglycerides are bad.
No, not necessarily. That's highly conditional. Triglycerides are the packaged, stored forms of fat. Triglycerides tend to be highly associated with reported fructose consumption. Mechanistically, it makes complete sense. It tends to be associated with really just carbohydrate consumption in general, and particularly standard American diets, which involve a bunch of fat and carbohydrates, which is the worst combination. Randall cycle. Look into that and actually understand it. There's nuance there too, but anyway. Yeah, so high triglycerides, yes, they're associated with negative outcomes. They're associated with obesity, debilitating obesity. They're associated with insulin resistance. So really we should say diabetes, which is not good, chronically elevated blood glucose. So that's not good. But triglycerides themselves are not harmful. Not to say that you said that. You're saying it's indicative of a problem, fine. But still, not necessarily. You know what happens whenever people are losing weight, typically? Rapidly? Well, if you actually know the process of glyceroneogenesis, which is not taught in biochemistry classes, it will be taught in mine whenever I have that out. And if you're one of the 20 that's recruited into the early access program, congratulations to you. Saying that face to face. To help shape the course materials and help build it. But yeah, it will be taught there. You'll actually realize that in the organisms observed, it seems that about 75%, 74 to 75% of the fat that is released through lipolysis, so the breakdown of your stored fat, is actually recycled. Because it seems to be the case that the chemical pressure for lipolysis, depending on circumstances, is so high that you actually don't need all that fat at that moment, which is interesting, by the way. It could also just be because you're breaking down the fat, but not for energy production through beta oxidation, but for like glucose production again, and then recycling it. Like I have to review the papers again. It's been a long, long time since I've done that. It's one of the great reasons. It's a great thing about me doing this course because I'm rusty on some things, and it's a great way to rekindle that flame. So anyway, yeah. So what happens whenever they're repackaged and recycled? Do they get packaged up into triglycerides? Boom. Well, that could explain something. So if you're rapidly losing weight in the form of fat, is that necessarily bad then if your triglycerides go up? No. So no, it's another faulty generalization here.
You get high triglycerides from eating a low quality carbohydrate diet.
All right. So not necessarily. In fact, a great way of doing it is if you were eating a standard diet with a bunch of fat alongside it too. Not to say that fat's bad. You'll struggle to find a figure in the space that's more objective than me, I would suspect. I would posit. Um, but it's true. Like, not but, so it's true. Like, I'm saying that it's true. Low quality carbs, though, that's an interesting framing of the situation, because all carbohydrates beyond the amount that is most indicated for us to have to be consuming is contraindicated. It is. Okay. There is some nuance, even with. There's always nuance. Okay. Nuance is intimidating for some. It's fun for others. Um, what I mean by that is just because our genes most evolved to withstand something doesn't mean that we can not adapt to something that could actually make our lives a lot better. What I say is you have to be careful with those deviations, and it really gets into a discussion about conservatism versus progressivism, not politically, but in this situation. How far away ought we to deviate, and does that vary depending on what type of stimulus we're talking about? Diet, other forms of lifestyle, etc. The answer is yes, it seems. But for example, I'm sitting in front of a computer screen right now, and I'm watching a video in front of a camera with a bunch of artificial lights around me in a climate-controlled environment. So does that mean that we should just revert all the way back to completely natural living? No. Does it make our lives better or worse? What's the net? You have to measure the net too, not the absolute, but the relative. So there's some nuance there, but again, with diet, I think that we should be a lot more conservative in that respect. Because, well, look around you. Too stark of a difference too quickly. And, well, that's going to cause problems no matter what, even if long term, theoretically, it were to actually improve our lives. But it also doesn't seem like even over a long term it would improve our lives, because look at the food chain. Who are at the top? Carnivores. We were the apex predators, and still, in a way, we still are. It's just in different ways. It, you know, it was a carnivorous animal, that being us. It's an energy pyramid that I'm referring to. So do we really want to regress to the plant eaters or the omnivores even? Yeah, I don't think so. I don't think that's a good idea. So anyway, with low quality carbs, yeah, no, they all break down to the same thing: glucose, fructose, galactose, from sucrose, maltose, lactose, or from directly glucose, fructose, and galactose. You also got sorbitol, sugar alcohol, which doesn't seem to be good either. So,
Or simply being overweight. Now,
Perhaps, yes, because then you could get, yeah. You can get a slowing of the rate at which you can actually deposit fat into your fat cells because they are reaching a maximum hypertrophy level.
If you have all three of these elevated, you are at super high risk to have.
No, because risk can't be informed upon in human nutrition science unless you were to say that the word risk is merely your opinion, in which case you would be correct. That is your opinion. It is a fact that is your opinion. So anyway, okay, you're at risk for what? Heart disease, I suppose, because of the graphic on the screen. You'll see it right now.
Have some critical blood vessels blocked. This disease.
Right, so not even necessarily. But yeah, so you do realize that none of that really has to do particularly with cholesterol consumption or saturated fat consumption, which seems to be more correlative with LDL levels than actual direct cholesterol, that's dietary cholesterol.
Is called atherosclerosis. When was the last time you had all three of these checked? Being young.
Never, I don't think. I don't think I've ever gotten a lipid panel, and neither do I plan on doing so.
Doesn't necessarily protect you, but hopefully it'll buy you some time. Now, the first symptom of atherosclerosis are skin changes, hair loss, especially in the lower limbs. People will notice that, my legs aren't so hairy anymore. Maybe you don't have hair on your toes. Your skin may start looking smooth and shiny. And then you may feel tingling in your toes. That's nerve damage. That's a form of neuropathy. And as you can imagine, over time, this will affect your mobility. These changes.
Look into diabetic neuropathy. So this is something else, by the way. I wasn't even thinking about this. Early signs of atherosclerosis. Really? Necessarily? Or are these possibly associated with atherosclerosis because of the other things that are going on, like diabetes, basically, which is highly correlated with atherosclerosis? In fact, 70% or so of people with diabetes, at least at the time of the study's conduction and the data collection, 70% of people with diabetes, I believe, die of cardiovascular disease. What do you know? Why do you think that is? Perhaps because the glucose damages your tissues. Oh, wait, yeah, it goes back to damage. Damage to arteries, causing plaque.
Takes several decades. People oftentimes don't notice the skin changes, but they do notice low back pain and impotence. The end stage of atherosclerosis presents in the 60s with heart attacks, strokes, kidney failures, and lung infections.
Right. So notice how she's being objective here, but whether she realizes it or not, she is stoking fear into people. And she's probably unconsciously, but perhaps even consciously, if you're on the cynical side, making other people unconsciously associate all of these things with cholesterol. Because she didn't mention diet, but as soon as you say cholesterol or any of these other things, people immediately go, well, you get cholesterol from food. So it's a primitive mindset. It speaks to our primitive mind, these claims. So it's not to say that those people that think that thing unconsciously are primitive minded. We have a primitive part of our brain, and it speaks to that. And so this is what's happening right now. That's why I'm here.
So if you're on Facebook and your friends are having funerals, you should really think about how to change that for yourself. If you don't.
Right. So it has no real relevance to ABO B, LP little a, at all. So
Want to have these complications and spend the last 12 years of your life sick, then you really need to get those labs checked and understand how cholesterol relates to your overall health. Getting it wrong.
Right. So that is very important to understand. You don't seem to understand it at all. You definitely don't, actually. You just conveyed that in the beginning. You don't understand this.
Can mean a loss of health. Higher cholesterol levels mean you will have higher apolipoprotein B levels.
No, not necessarily at all. No, false. But even so, that doesn't matter. You are an MD, and I suggest that you actually stick to your job and stick to your profession. Because clearly, if you did any private studying at all, it was not adequate. Not in terms of its amount, but in terms of its quality. Yeah, not in terms of quantity, but quality.
So keeping your apolipoprotein low keeps the debris out of your blood vessels.
No, that's absolute nonsense, Lou. Absolute nonsense. You see, once again, all of those plaques are present within atherosclerotic lesions. It's damage to arteries. If cholesterol caused heart disease on its own, then you would see plaque building up in every single part of the vascular system. It doesn't. It occurs in set sites of the vascular system, particularly the arterial side, not the venous side. It doesn't occur in veins at all, despite the fact that, once again, the entire vascular system carries the same cholesterol content. The only difference in the arterial system, there's only two. One is that it carries oxygen, and the other is that it's a higher pressure area. In terms of like relevant, like broad, significant differences in the significance salience hierarchy. Okay. Well, not only does it only occur in the arterial side, though, it also occurs, particularly, primarily, only, really, in set sites of the arteries, the arterial system. Those being the sites that experience the most turbulent blood flow. Turbulence just being a deviation away from a smooth and steady flow in terms of a fluid, which causes pools and eddyings of blood. Okay. They're where the bifurcations occur with major arteries. The inverted U shape of the aortic arch is a perfect example of this. And the turbulence actually is what causes the most damage. And the turbulent blood flow, where there's pools and eddying, is where the plaque actually develops. To take the inverted U shape as an example, it's not the high shear stress of the blood pumping right at the underside of the U. Do you think of that? That's not what develops the plaque. It actually is on the undersides of the U shape, the inverted U shape, because that's where the most turbulent blood flow occurs. That's exacerbated by hypertension, high blood pressure, because physically speaking, and by physically I mean pertaining to the study of physics, that's what's going to cause the most damage. If the blood flow, the higher pressure, well, think of a hose. So, no, cholesterol doesn't cause heart disease, and the debris that you're talking about is really scar tissue. It's scar tissue. They are microcalluses, ma'am. So, no, we're done here.
And that's advantageous to keep your blood flow. So how
Well, of course it is. What's unfortunate is the fact that you completely got this wrong, and now you're going to talk about how to lower your ApoB, which is now just a complete waste of time. It's a complete waste of time.
do you keep apolipoprotein B levels low?
Right, so this study right here is now saying the lower the ApoB, the better, which is just complete nonsense. It's complete nonsense. Now, how does ApoB fit in the upcoming era of targeted therapeutics? Well, I mean, if only that were actually relevant, because it's not relevant at all, and we already covered it. So that's an editorial, it says. So it says, yeah, it says it's an editorial, originally published August 29th, 2022. So it's probably, yeah, it's just an opinion piece. I mean, that really is just an opinion piece. So, yeah, well, I think once again, we're done there.
Apolipoprotein B levels low. Well, you need to lower your cholesterol.
Well, no, because not all the lipoproteins actually carry ApoB. Oh boy! Wow, good. Anyway, once again, I think this is just going to be a waste of time now. So now we're going to get into how she just completely misrepresents science even more. I'm waiting for that. Because even if you're just going to jump in the ring that they've sort of constructed in their ring, assuming that the ring is based on a sturdy foundation, which it isn't, but just to have fun and like fight within their own logical confines, it's probably gonna it's still gonna fall apart. It's still gonna, I'll show you exactly what I'm talking about soon, I suspect.
Specifically, the LDL cholesterol.
There you go, which isn't cholesterol, it's a lipoprotein. We already covered that.
However, lowering cholesterol in your diet doesn't really help you lower your apolipoprotein B level.
Well, there's no evidence to support that claim, actually. What is supportable is the fact that it's not associated with lower cholesterol levels. That's the key. The mechanism is very clear because, like I said, in the body, there's always diminishing returns, absorption rates, enzyme rate of function. Michaelis-Menten kinetics, actually, when you learn that in biochemistry, you'll actually understand exactly what I'm talking about. And we cover that in my course too, or at least we will. Anyway, yeah, so you've got cholesterol absorption that occurs until you get enough of it, and then boom, done. So it actually seems that saturated fat is more correlated with it in the studies done. So that's the key. So I tend to agree with that, but
By very much. And the reason is because the biggest organ responsible for your cholesterol levels is your liver. The liver makes
yes. So yeah, basically what you're saying is that if the body is not getting enough cholesterol exogenously, then it will, to the best of its genotypic abilities, given your genotype and your phenotype actually, but it will produce more. It's almost like it's really important for the body to have. Now, just because it's really important for the body to have, that doesn't mean that you should be consuming it, because you can literally make that exact same argument, and it's made all the time for glucose. If you don't consume the glucose, your liver will just produce all the glucose you need. Yeah, that just goes to show how important glucose is. It's the same exact argument. The difference is how long have our species members throughout history encountered exogenous cholesterol? Compare that to glucose. That it literally always comes down to that. Always. What is cholesterol's ubiquity compared to glucose's ubiquity in the wild? Blah.
cholesterol and removes cholesterol. It helps you keep blood cholesterol in balance.
Right. So there we go. So stop trying to worry about your cholesterol levels because your liver basically regulates it all. Cool. Eat an indicated diet, species appropriate, species specific diet for our genome, our speciation, that being Homo sapiens sapien, which is a carnivorous diet consisting primarily of the flesh and associated fat of large ruminant animals with added fat, not because that is ancestrally consistent, but because of our modern context, given our modern world. To taste in the forms of butter, tallow, lard, suet, and ghee, added salt to taste, and water, transitioning appropriately, prudently over the course of 6 to 8 weeks to ensure that your adaptation does not go not smoothly. So, there you go. No carbohydrates to speak of at all. And there's minimal variation around that constructed diet because of humans' ubiquity for the last little less than 13,000 years. It was it was a slow permeation of our ubiquity since 13,000 years ago. It wasn't like 13,000 years ago, boom, ubiquitous. Just flip a switch. It was a slow, gradual migration. But yeah, which also influences that. But still, we're the same species. And every species has one diet for its speciation. So before people say, well, now you're contradicting yourself. In order to conduct a proper nutrition study, you have to have genotypic and phenotypic, you have to have identical genotypes and phenotypes for all people. That's an unrealistic standard. But even if that is your standard, you're contradicting yourself, because then you say that on one hand, but then on the other hand, you say that every single species or all humans should eat the same diet, despite the fact that we all have different genotypes and phenotypes. Yes, because a species diet doesn't discriminate based on genotype or phenotype. mainly genotype, but even then, even phenotype, really. It's just with us, our phenotypes are so starkly different that perhaps there could be some nuance there. I talked about that with Faith, a member of our carnivore certification program, nutrition program. We also have a fitness program affiliated with Carnivore Coach Peter. If you're not a member of that, you're missing out because you have the opportunity to become internationally accredited as a nutrition and possibly, depending on what you decide to do, fitness coach, which gets you an easier acquisition of insurance to protect yourself and also allows you to actually directly talk with medical professionals like Lou here, theoretically. So you can actually be taken seriously by doctors instead of being dismissed by them. Very good idea. I highly recommend it. Highly. So, yes, one of our certified carnivore coaches, Faith, I talked to her about this, how you could, during development, especially if you develop with a really, really starkly different phenotype than what would have been exhibited before with other genotypes in the past, in our ancestral past, then you could have a genotype or you could have a phenotype later on in life that is causing you to, it's basically functioning as a pseudo genotype where there's really no way to change it back to yeah, maybe you then you have such bad metabolic derangement that you need some carbs in your diet or something or some oxalates, which is unfortunate, but it doesn't mean that our species appropriate diet is that which is teeming with oxalates and carbohydrates. So anyway,
If you want to lower your apolipoprotein B levels, you need to understand.
Which I don't at all because I don't care, and that's because I don't actually understand the science behind heart disease, cardiovascular pathophysiology with respect to atherosclerosis development.
Why your body even needs blood cholesterol when every cell in your body can make its own cholesterol.
Yes, hold on a minute. I want to make sure that I cover every last iota of what you said. Let's rewind and make sure that I didn't miss something that you said. Let's hope that it wasn't too egregious.
Lipoprotein B levels, you need to understand why your body even needs blood cholesterol when every cell in your body can make its own cholesterol.
Lou, your body can make its own a lot of things. It has the ability to synthesize many amino acids on its own. The question is whether or not relying on that is sufficient for thriving, for an indicated affect and presentation, or whether it's sufficient for mere survival. That question is not clearly answered scientifically because science has many, 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 many limitations, which is why, once again, we're going back to what we did for millions of years. It is not an appeal to tradition fallacy. It is an appeal to biology, which is an actual hard science. It is an appeal to evolutionary biology, which is the prevailing scientific theory for a reason. And it also includes in that conclusion also considers antagonistic pleiotropy, which hasn't been proven in terms of with respect. Antagonistic pleiotropy as a phenomenon has pretty substantial backing. I'm not saying that. I'm saying with respect to a carnivorous approach to diet, it has not been proven. And also, even if you were to say, well, look at all that meat, it might cut like 10 years off of your lifespan, though, because of antagonistic pleiotropy. Yeah. So what's the alternative? What's the alternative? Genuine question. Is the alternative to live a longer life eating a bunch of oxalates and carbohydrates that are not really going to cause um, your health to be the best, your performance to be the best? I mean, really, would you trade 10 years of your life to have the best performance that you could ever have? The answer would probably be yes, I would suspect. And that's exactly how evolution works. You got all these benefits, and it was a trade-off. If antagonistic pleiotropy in this respect, in this area, were actually proven to be true. which it hasn't. And by the way, it doesn't seem to be true at all. It seems that we actually have the ability to live up to 120 to 150, actually, years of age when you do comparative gene analyses with our genes to other species. If we just stopped being stupid. And let me be a little more forgiving. I like being forgiving here, believe it or not. It's not necessarily us being stupid. It is us experimenting, trying to make our lives better in many cases. But sometimes we can be very impetuous and we can get ahead of ourselves in that regard. So sometimes it is stupidity, even if the stupidity is innocent, because there is a level of, there is innocent ignorance and then guilty ignorance. But irresponsible is probably the better word to use. Irresponsible ignorance, but that gets to a more abstract ethical conversation. But yeah, let me just be as forgiving as possible. It is us trying to get our lives better, but if we have that potential, it seems. So let's try and reach that potential. If you can also reach that potential while maintaining health span, which seems to be the case with the carnivorous approach. Why wouldn't it be? So, okay, continue.
Cholesterol is a type of fat called sterol that
It's a type of alcohol and lipid, yes. Okay, yeah, fine.
is needed to make the bag that holds each and every one of your cells. And cholesterol
It makes up your cell membrane. What is lipid rafts? Yes, lipid rafts. That's what I was thinking of. It makes up your lipid rafts, which is kind of where it's like a junction between cholesterol and then a bunch of phospholipids in the phospholipid bilayer of your cell membranes.
Of course, you're probably concerned because it makes essential hormones like
Yes, it does. It's the foundation of them. It's the backbone of all of your steroid hormones. Testosterone, progesterone, you got glucocorticoids, androgens, all of those.
cortisol, estrogen, testosterone. These all need cholesterol, including your body's ability to make vitamin D. Fortunately, these hormones, even your testosterone level,
Cholesterol intake and serum total cholesterol levels are not associated with total testosterone levels in men. Right, okay. So this gets into a discussion regarding presentation versus blood levels. Is it the case that just because you exhibit, no, I think we actually covered this in the beginning. So normal testosterone levels. Oh my God, so many questions here. Wow. This is why my videos are so long. So many things to touch on. If you exhibit a normal testosterone level, again, what do we mean by normal? We covered all that in the beginning. Does that mean that you're exhibiting adequate testosterone for your needs, adequate testosterone activity for your needs, and for you to live the most indicated lifestyle possible? If you're outside of those ranges, are you exhibiting levels that are not adequate for your indicated level according to your genotype? Sean Baker has what's considered really low testosterone all the time, every single time he's had it tested. Have you seen the guy? Now, you can't extrapolate his findings to every single person and say, well, therefore, if your testosterone's that low, then it must not be a problem. But what you can say is if it can happen in one person, well, then clearly it can happen to others too. It's possible. It was proven. There's the exception. Done. An exception. So cholesterol, okay, so let's actually break this down. Cholesterol intake, right. According to whom, on the basis of what? Collected via what methods? No, it was reported cholesterol intake according to food frequency questionnaires, or, a cross-sectional study. There you go. Longitudinal. For 1 year, 1 year, one. Okay? So was this a prospective cohort study then? Because that would mean that there was an intervention group and then a control group, which resulted in a ratio that was formed. So then puts into question the absolute values and what they translate to in terms of what that ratio is as a relative term into an absolute term are not associated, right, with total testosterone levels. Yeah. So cholesterol intake, yeah, as reported, and serum total cholesterol levels, yeah, are not associated with total testosterone levels in men. Okay, so this was also in men. Fine. A cross-sectional study from N. Haynes, 2013 to 2014. Yeah, I think we're done. This science can't really inform upon jack. So what? What really should be assessed is the disease, the presentation of these people, and also for 1 year. So can the results of these studies, can the results of the study be extrapolated to any point beyond 1 year, and to any other population not studied? Yeah, the answer is no. No.
Level is not dependent on your total blood cholesterol level.
First of all, actually, the study didn't show that. It didn't show that it wasn't dependent, because that's basically just making a causal claim. It said that it wasn't associated. Okay, what you've just done is you've engaged in the fallacy that involves the belief that a lack of an association means a lack of causation, which is false. Two variables that are causally linked in a vacuum can actually exhibit no association whatsoever of any significance outside of the vacuum, because all of those other confounders and spurious variables that get introduced when you exit the vacuum can uncouple the link between X and Y. Okay? That's how that works. Statistics, logic, reasoning, epistemology.
So even if you took medications to lower your blood cholesterol,
Which you shouldn't do, because those are not medications, those are poisons. Good. Those are drugs.
your testosterone won't be affected.
No, that's not what the study showed. And that was, by the way, one study over the course of 1 year on a population that, well, a subset of the population, let's just say a population because it's more accurate, on a population of people with an unspecified sample size, with an unspecified strength of the association, with an unspecified hazard ratio, incidence ratio, that was most likely, by my estimation, reported via relative values and not absolute values. So we're done. How reproducible is that study? And even if it is reproducible, who gives a because look at the study.
However, you do need that blood cholesterol for bile, which your liver also produces.
Yep. Yeah, it does. Bile consists of a lot of things: phospholipids, cholesterol, like you said, water, amino acids. Well, bile salts consist of, amino acids, taurine, and then I think glycine, I believe. Maybe not. Can't remember. That gets into lipoprotein metabolism. But yeah, got stuff there too.
And you need bile to help you digest fat.
Correct. There you go.
Now, this function turns out to be a great way to help you lower cholesterol. And
Well, that puts into question a very serious question, which is, why do you want to do that in the first place? Should you do it, rather? And the answer is no, you shouldn't. You shouldn't. You should seek to mitigate the damage that you've incurred to your arteries.
here's how it works. When you eat food, your body will secrete bile to help you digest that food into.
No, when you eat fat, that's what happens, actually. Triglycerides actually interact with the gastric mucosa through chemoreceptors, which stimulates cholecystokinin. I believe it's cholecystokinin. Again, rusty, very rusty on this. But let's just say, for the sake of the argument, that's true. Cholecystokinin then migrates to the liver and activates smooth muscle in the cystic duct of the liver to help secrete the bile through the main hepatic ducts into the stomach. Again, this will be taught in biochemistry, lipoprotein metabolism. And then alongside that, typically what happens is the pancreas will release pancreatic lipase, sort of through that same pathway, actually. And then that lipase works with a cofactor called colipase and is activated through trypsin, I believe, and works to basically break down those triglycerides into, I believe, micelles. Could be getting a few things wrong. Either way, the bile is involved in breaking down fat to eventually form a bunch of monoglycerides and diglycerides, and then they're absorbed into chylomicrons, transferred through the lymphatic system, they enter through the thoracic duct into the bloodstream, and then according to the I to G ratio, are either broken down in muscle cells or fat cells for storage or utilization. After doing sort of trade-off reactions with HDL, by the way, through for ApoC2 receptors and also ApoE receptors, which is then that gets into ApoE genes, you know, the ApoE, the differences in those things. So ApoE4, ApoE3, all ApoE2. So yeah. So yeah, it's eating fat actually that stimulates bile production, not eating food.
Your intestine. And normally your body will reabsorb 95% of that bile that you secrete, which is great for your liver because then it doesn't have to do as much work. But if the bile doesn't get recycled, well, that forces your liver to pull in more cholesterol from your blood, which...
Right. Oh, so I see. So basically what you're doing is you're sabotaging the body. You're basically talking about bile salt sequestrants here. I mean, do you do realize this is what they're talking about? I'm less and less angry the more I react to these videos because you can well, it's really hard to hate someone. I'm not saying it's impossible. It's really hard to like hate someone. Not to say that I've ever hated anybody on this, you know, on this endeavor of mine, reacting to these people, but it's it's really hard to hate someone and vehemently despise what they're saying, whatever it may be, when you really understand the logic behind it, like truly understand it. You can understand why she's saying this. But it is, by definition, it is misanthropic. It is antithetical to what the genes are evolved to withstand. I mean, it's like someone. Imagine that you existed on this earth for billions of years, and someone of her age went up to you and said, "Hey, you know that thing that you're doing right now? You're doing it wrong, right?" Like, how would you feel? You'd go. You'd actually be taken aback, I think, at the amount of arrogance that takes. But they don't see it that way. They don't see it that way. But anyway,
then lowers your apolipoprotein B levels. So the best way to prevent cholesterol recycling is to poop. If you have frequent...
Well, hold on a minute. Okay, so now you're not even talking about pharmaceuticals. You're talking about holistic approaches. So okay. All right. All right. Ma'am. This is unbelievable. Seriously? So now you're going to tell people to eat a bunch of fiber and plants. Because the more waste you eat, the more waste you excrete. As I say, fiber is indigestible plant material. Yeah, fiber is an indigestible plant compound, and last I checked, if you can't digest something, you shouldn't be eating it. There's no requirement for it. There's no deficiency disease that has ever been observed over any period of time in any given population of people from the abstention of fiber. And from many, many, many anecdotes and personal experiences that have been shared of people that have eliminated fiber from their lives, not only is there no deficiency disease in them too, but also they seem to have ameliorated many bowel issues, which makes sense because it literally abrades the enteric lining. Why do you think it's associated with increased mucus secretion? Name one instance in the body where mucus secretion occurs in an upregulated fashion outside of the context of the tissue concerned being irritated. When my nose starts running more than usual, typically that's because it's been irritated by something, an allergen, for example. What do you think mucus is for? So anyway, no, fiber is a contraindication in the human diet. I think it's very clear. It really is clear. So
bowel movements multiple times a day, you can significantly reduce your cholesterol levels.
Really? So that happens in everyone? Has that actually been observed? Really? Seriously? You're looking at an association. Truly, I mean, that is what you're doing. That is what you're doing. Let me do a quick search real quick. Very, very quickly. And I'll go ahead and look and see if fat is not the only thing that stimulates cholecystokinin, because if true, then I suppose that what she's saying is correct, and I'm not afraid to admit that. So a cursory little search basically proves my point to be correct. Apparently, it's not the gastric mucosa in which it's released, but it's the jejunal mucosa, which fine, whatever. But fat is the strongest stimulator, because why wouldn't it be? Protein also stimulates it to some degree. Okay, fine. Probably because protein is associated with fat, but okay. Carbohydrates are much weaker stimulants, and then also fiber doesn't stimulate it at all, which was actually what I was trying to say here this whole time. So what's a great way of increasing your bowel motions? Well, it's consuming a lot of waste. It's not consuming carbohydrates, actually. Um, that's not the way to do it, but okay. Great stuff. Great.
That is, if you can trap the bile. So this means you have to eat more soluble fiber. Soluble fiber.
Right. So this is different. So you're admitting, by the way, so notice that what she's doing is admitting that soluble fiber is an anti-nutrient, because it doesn't just take bile up. It takes up much other nutrition as well. Yep. It's literally an anti-nutrient. She's admitting it with a straight face. Keep that in mind. So what she's telling you is to eat soluble fiber along with all of your other fats and stuff, causing the bile to not be recycled. So it's taken out of the body, so that your liver has to produce more. You're sabotaging the body. Good. Okay. So I think that we're done here. No, don't do that either.
Fiber are carbohydrates found in grains like whole oats, fruits, and seeds like.
Uh-huh. It's also found in many of these as insoluble fiber, which is, I mean, just based on mechanism alone, I would suspect is probably the most harmful. It's not fermentable at all. It is the most indigestible out of all of them. If indigestibility is, if indigestion was a spectrum or something. Yeah, so again, same thing there. Don't do that. No reason to do that at all.
Chia seeds, flax seeds. Hey, doesn't that sound like a pretty good breakfast?
No, it doesn't at all. Unless you're talking about putting honey on it and a bunch of sugar in it to make it palatable. Take the honey and sugar out. Take all the sugar out, and then try and eat that with alacrity. Go ahead and do that. I'd love to see that.
When you eat these foods with soluble fiber, your body can't really digest it. So,
wow, good. Do you realize, like, now that you have a clear mind, my dear viewer, and you have woken up to the carnivore way of eating, this sounds like it actually sounds like egregious propaganda now. It doesn't even sound like she's making sense. She's literally telling you to sabotage your body's mechanisms, your body's processes. She's literally telling you that.
it traps in the bile. And on top of that, when you eat these plants, you also get sterols and stanols.
So you're getting phytosterols. Sterols, instead of cholesterol, you're getting phytosterols that basically replace cholesterol in cell membranes due to the similarity in their structures, which probably derange them, considering how we understand that certain plant compounds, because I list a lot off: lectins, oxalates, tannins, phytates, saponins, goitrogens, isothiocyanates, salicylates. Okay, we list all those, right? There are others like attractylicides as well, but there's others. If I can remember what they're called, glycoalkaloids. Yes, glycoalkaloids. Well, they compete with cholesterol for absorption in cell membranes, causing the cells to leak or burst upon impact, because cholesterol is very important in maintaining cellular integrity, cellular fluidity, and all that stuff, which is also dependent on temperature, high versus low temperatures, but nevertheless. Um, but also, there is something else they're involved in, which has to do with the neurotransmitter. Oh, yes, they inhibit the enzyme acetylcholinesterase. Yeah. Or really cholinesterase, which is responsible for breaking down acetylcholine, which is a neurotransmitter. So whenever you break it down, you can actually suffer from um, what do you have? You've got basically respiratory arrest and paralysis because the neurotransmitters are involved in the activation of nerves to cause muscle contractions and all that stuff, and to also release muscle contractions for the action potentials and stuff like that. Those action potentials not actually being potentials at all because there's no potential there in terms of a charge because of the law of electroneutrality, which is always present at all times in all aqueous solutions under every single circumstance. So, anyway, the pH changes, but not the charge. So the reason I bring that up is because, well, glycoalkaloids do the same thing that she's saying that these sterols do. Well, if anything, competing with cholesterol for absorption because of similarity in structure is going to decrease cellular fluidity and really cellular integrity. So not good. You know, you can actually get it seems that you can get an artificially lowered HbA1c value by doing exactly that, consuming phytosterols instead of cholesterol. And the reason for that seems to be, and I think I believe this entirely, the integrity of the red blood cells that are measured for an HbA1c value is so low, it becomes low, so they die more frequently. So you have a more frequent reticulocyte production rate, which are like baby red blood cells, which lowers your HbA1c value because they have less time to accrue glycation damage. That's why people with hemolytic anemia actually have a high association with a low HbA1c value, despite the fact that they can actually be diabetic, according to their blood glucose readings, and a fructosamine assay as well. So yeah, now you're telling people to consume a bunch of disparate parts of an operating system.
Compete with cholesterol absorption. That too reduces how much cholesterol you can resorb from your bile. And
Resorb. Is that a word? Perhaps it is. Anyway. So once again, same comments here. We already covered that.
this is why people who eat predominantly a whole food plant-based diet, they can significantly drop their blood cholesterol. Now,
well, no, what you're talking about is an association, so the word can is irresponsible to be using there. Also, no, reported consumption, but either way, putting all of that aside, that begs a very important question. Is that a good thing or not? Is that indicated? And it's not, very clearly, according to the Darwinian principles of evolution and the subsequent principles of indication.
I mentioned cholesterol doesn't really elevate your blood cholesterol levels.
It isn't associated with an elevation of blood cholesterol levels beyond the baseline that is observed to be the baseline in the population studied for the amount of time that they've been studied and for the amount of times that the studies have been conducted on different populations, perhaps. You see how you just yeah.
And that's because your body is very inefficient at absorbing dietary cholesterol. Like I said, most
Well, that depends on your phenotype, doesn't it? You keep saying your body. You're just making massive generalizations.
of the cholesterol in your bloodstream is made by your liver, and your liver makes cholesterol in response to saturated fat.
Yep. Because acetyl-CoA is the primary intermediate for many, many substrates, including cholesterol, including ketones, including ATP, through the Krebs cycle. Yeah, HMG-CoA reductase is a primary, I think it's a rate-limiting step, actually, or rate-limiting enzyme of the cholesterol synthesis. But I believe that there's many ways that you can synthesize cholesterol. Cholesterol synthesis is another lesson that you learn in biochemistry. And you actually realize that the pathway for synthesizing cholesterol is about 30 steps long. At least the one that's taught. So, womp womp, yikes. Now, why do I say yikes? Because when you target that tree, that 30-step tree with a drug, to just target one part of that, one branch of that tree, you can imagine all the other ramifications you'll have. You're taking a risk.
So if you eat a lot of saturated fat, it's going to make cholesterol. And
well, yes, sure, until you hit a diminishing return. Do you think that the relationship between saturated fat intake and cholesterol is linear all the way through? There's no diminishing return? I mean, seriously. No, it looks like this. I can't remember the names of those. There's like, there's a name for those two associations. Or those two functions. Again, going back to biochemistry. You would think it's mathematics. I mean, it's a little bit of both, but yeah. Yeah, first order kinetics is like the linear one, and then it reaches zero order kinetics. The diminishing return. Yeah. Gosh. Wow. Anyway, yeah, it's a diminishing return. So yeah, do you think that if you just eat a bunch of cholesterol and your cholesterol levels, or if you eat a bunch of saturated fat, your cholesterol levels will go up to 900 necessarily, if at all? Give me a break.
the simple reason is because you need cholesterol to transport saturated fat. In your
Well, oh my God. Ma'am, this woman actually thinks that lipoproteins are cholesterol. Oh my God. No, you don't. You need lipoproteins. Chylomicrons. Wow.
blood, there's a molecule called low density lipoprotein.
Uh-huh. So we already covered this. It's not cholesterol. Why do you think everyone seems to think, well, no, it's a pedantic point to say cholesterol. Lipoproteins aren't cholesterol. Yeah, well, clearly it isn't. Clearly it isn't pedantic. It actually is important.
That stands for LDL. I'm sure you've heard of it. We'll look into this a little later. Now, if you're following social media, you know that there are heated debates about whether or not high LDL cholesterol matters or small particle LDL, are they more damaging?
They're not, none of them are damaging. None of them are damaging.
Each cholesterol camp is adamant that they are right and the other side is wrong. There's even a new group of people called citizen scientists who think that they are special because they are lean mass hyperresponders.
Oh, wow. So did you say that in a snarky way? Because I really hope you didn't. I'm not innocent until proven guilty. Perhaps my perception of the truth is off. But lean mass hyperresponders is a construct. People that are super lean but exhibit high cholesterol levels. Which, good for them, man. I mean, I'm like, sure. Great. Maybe I'm one of them. I'll probably never know.
They think that their high blood cholesterol doesn't really matter, that they're protected because they have other good metabolic parameters and they're not overweight.
Right. That is the problem with that. Arriving at that conclusion through those means is not exactly the best. That's not. Well, I have good musculature. I've got good VO2 max. I've got, it's like, okay, great. But could the cholesterol still be a problem? Then you actually dig into the reasons why it's not, and then you realize it's not. So, I mean, there you go.
Look metabolically fit and they have low triglycerides, low hemoglobin A1C numbers, but they have super high LDL cholesterol levels.
Well, they also might have high hemoglobin A1C, which also doesn't necessarily indicate a problem because that is highly conditional. Length of red blood cell lifespan, for example, is a big one.
Over 200, sometimes over 500. That occurs because they adopted a carbohydrate restricted high fat diet.
Well, there you go. And by restricted, it should be carbohydrate bereft.
And recently they published a 5-year study that looked
Carbohydrate restriction induced elevations in LDL cholesterol and atherosclerosis, the keto trial. Is that the one that I reacted to on? All right. I think that's the one that I reacted to on my in my catalog, which was an atrocious study. If I'm thinking of the right study. The study was bad. It shouldn't have ever been published. And in fact, it got a lot of pushback also because of the PR handling. It was not good. It was an awful regression with non-normally distributed residuals and 100 people over 1 year. Many other problems with the study as well.
At the coronary plaque formation in 80 lean mass hyperresponse.
80. Right. I know that you have to start somewhere. But if you're going to release a study as a start to something, then advertise it as such.
They were predominantly white male, and their average cholesterol level was 369, plus or minus 95. Now, the number, according to the American Heart Association, is a super bad LDL cholesterol level.
Wow. And didn't you say at the beginning that they could be wrong about things? So you're just appealing to authority? You're an MD, Lou. I'm rooting for you. I'm on your side. Okay? In terms of, I want you to come over to our side. Like, I'm rooting for you to understand and learn the truth. I am. I really am. This isn't it, though. This really isn't.
The paper found no increase in coronary plaque formation compared to the matched controls who weren't on a low.
I'm sorry, 80 people with a control group too, which means that they split them. So they were studying 40 to 40, right? Wow.
Low carb diet. They matched smoking status, hypertension, age, and race. And those factors all would increase the rate at coronary plaque would form. And since they found no difference in plaque formation, they concluded that their carb-restricted diet, because of their unique circumstance being a lean mass hyperresponder, that their LDL level was safe, that they didn't need to worry about it.
From that logic alone, you cannot arrive responsibly to that conclusion. That is an opinion. I just told you the reasons why we don't have to worry about ApoB and LDL and all the blah, 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 all the other ones, all the other subfractions of lipoproteins, all the other types of lipoproteins. You don't need to worry about them. I just gave you the actual hard science, the hemodynamics, the physics behind heart disease.
Well, unfortunately, their study has quite a few fatal flaws.
Oh, well, Lou, I love how you're just basically only going to be you're only going to peruse and pore over the details of this study and not the other studies that you referenced in the beginning. Because I guarantee that the flaws that you're going to point out in this study can be extrapolated and applied to the other studies that you put up on the screen in a flashy, super brief fashion. So you're being extremely biased.
So on the surface, it seems like LDL cholesterol does not directly cause plaque formation, right?
No, that's not what it seems, because that's only a conclusion that you would arrive at if you had a very ignorant mindset regarding and surrounding science, statistics.
Right? Because they didn't have any difference between the control group and the test subjects. But plaque.
By the way, when we say control group, they weren't controlled, were they? Because can you control for human beings at all? The answer is no.
It takes more than 5 years to form. That's why.
Exactly. That's another thing. How long does heart disease really take to form? Yeah, decades, actually.
You don't get to age 5 and pass away. It takes several decades. Heard of?
Correct. That's a massive flaw in this study. Now, how long did that other study go on for that you mentioned? Was it 1 year? I know that the context is a lot different. I get it. The reason I bring it up, though, is because it's still relevant even in that context. Just not in the same way.
The women's health study that enrolled over 20,000 women who were considered to be metabolically healthy with normal blood sugars, low triglycerides, high HDL cholesterol, and high.
Which is not necessarily a good thing. I mean, it's good in the sense that it's exactly what the body is supposed to do given the circumstances, in their circumstances, sure.
high LDL cholesterol, and they
Not cholesterol. Covered that.
follow these women until they pass. After all, that is really why people worry about plaque or even high cholesterol numbers, right? Because people assume the more plaque you have, the higher your LDL cholesterol, the shorter you will live.
Right. So you see that word assume that you just used there? Exactly. Assume. They assume that to be true.
Notice that within the first 5 years in this graph, that there's really no difference between the different LDL cholesterol groups. The group starts to separate after 5 years.
All right, so I've just had a few seconds to look over this. That's really important to do whenever you're looking at any graph of this sort. You really want to analyze it first before commenting on it. Really what this is showing, you have your independent variable here, years since baseline blood draw. So do you already notice a problem here? What's the problem there? Years since baseline blood draw, and it goes up to 25, 30 years. So this is based on an assumption that their LDL, HDL, and all of their other values stayed the same for 30 years. Good. Great. So I think we can throw the study out the window right now, actually. But, no. We'll keep going. We'll keep going. Let's look at this even further. You've got 4 lines here which represent different groups. And then you've got on the y-axis as your dependent variable, survival probability. I already covered that it's not a probability. It's an incidence rate. Okay? And it's in the form of a ratio, 1.0, 0.9, 0.8. If it's in the form of a ratio, you immediately know that it is intervention over control. Now, this is a little confusing to me, considering, well, if you've got 4 different groups, or 4 different lines for 4 different groups, then why do you have a ratio here? Like, again, I'm not saying that this is stupid on their behalf. I could be missing something, but it doesn't really make any sense. 1.0 would be, I don't know, if they had one person, or like if they had 100 people that they were studying in the intervention group and 100 people in the control group, 100 over 100 equals 1.0. So 100 people are alive, 100 people are alive after 1 year. Then the survival ratio, or probability is what they call it, but it's not a probability. That would be 1. So did all 4 of these groups, were they all intervention versus control? That's what it seems to me. So let's just assume that that's true. What you see is over time, they start dying. Okay, and this is in over, what, 20,000 women is what she said in total across all 4? I mean, I'm not sure. But either way, you're seeing that, yeah, there's very little difference in terms of mortality in these groups of people. And this is also not to mention, what are the error bars? Well, in this case, I don't actually know if the error bars are relevant. In fact, they're not relevant at all. So they basically took the intervention group and the control group and the deaths and all that. Every single year, they tallied up a ratio for each group of women studied. And I believe that it's over 20,000, or it's about 20,000 or over 20,000 women were studied across all 4 of these, which means that it's about, I don't know, 5,000 in each group if it's proportionally distributed. So yeah, great. So you got Q1, Q2, Q3, Q4, Q5 up here as well. And that's confusing me a little bit because, well, I mean, why are these lines here? Is that what's relevant here? I mean, you've got Q5 though. That means that you've got what? You've got more than the amount that's actually listed on the graph. So that's a little confusing as well. I need more details about the study, but either way, what you're looking at is an association between people dying that exhibited a certain level of blood markers, plus or minus, by the way, the standard deviation. Okay, so we want to know the signal to noise ratio and all those random variables at baseline to see how strong that signal was. You've got that, and somehow you have 4 different groups as well, and you measure the incidence rate of death over time. So you're looking at an association, and even then, as you just said, there was very little difference. And this is only able to be extrapolated to the people that were studied, and particularly women that were studied. So good, great. What are we doing? Seriously, what are we doing here?
with the gap to early passing becoming even more prominent when you go out to 10 years, 15 years, and 20 years. In the recent paper, there were only 80 people in the study.
Yup. That's another limitation. That's a limitation with all science, Lou.
Studies usually enroll thousands of people. I mean, everybody has a heart. There are billions of people on this earth, so you should be.
Yep, and that demographic of people changes every second because of people that are born and people that die. So trying to extrapolate results from one study to an entire human population that changes every second is irresponsible. It would also be irresponsible even if it didn't change second by second, but whatever.
Able to recruit more than 80. Now, number 3, just because you don't show plaque in the coronary arteries doesn't mean you don't have atherosclerosis. Now, my friend who happens.
Yeah. Wait a minute. Whoa. Hold on a minute. Okay. So you're meaning you're saying that there could still be damage to arteries? Sure. Yes. Great. But this is now just speculative. So it's your opinion. By the way, I want to say that you want to know why they were only able to recruit that many people? First of all, carnivore is not as popular as all these other diets, but also money. Money, Lou. Now, what garners more money for funding a study? I'll let you decide the answer to that question.
Be a physician, told me that she recently got a coronary artery calcification score,
which only measures hard plaque, calcified plaque, not soft plaque. Now we have the ability to measure non-calcified plaque volume, but that is still not as informative.
And it was 0, a perfect score. So she was pretty confident. And by the way, she used to eat like crap, like French fries with salt and pepper every day for lunch. You know what I told her? 60% of people with a coronary artery calcification score of 0 had atherosclerotic plaque in at least one body part. And it's
right, because that is measuring hard plaque and not soft plaque.
Usually not your coronary arteries. And artery calcification scores would be different in different blood vessels. The first arteries to get blocked with plaque are not your heart. They're your femoral arteries that go to your feet and legs.
Well, that makes sense.
And this is what causes hair and skin changes to your lower extremities.
Well, that seems quite plausible. What I will say is the same thing that I said at the beginning, which is cholesterol is not the cause of this. It's damage to arteries. We're done.
Lower extremities. And eventually, if it progresses more, you're going to have muscle pain and cramps. And of course, all of that will affect your gait. Now, the second most common large artery that develops plaque are your carotid arteries. Over here is your carotid.
Yes, so we're talking about cardiovascular disease broadly, which includes stroke. Good. Yep.
Arteries, they bring blood to your brain. So before you have heart problems, you'll suffer with gait difficulties and memory issues. Now, number 4.
Potentially, yeah, makes sense.
It's been shown in multiple large trials that people below 60.
Again, with these randomized controlled trials that aren't controlled at all,
have a lower rate of having coronary artery disease.
In the people studied, they have a lower rate. Sure.
They're not going to have a positive coronary artery calcification score unless you have a family history of heart attacks at a young age.
Well, that's your speculation. That's your opinion.
And these people who inherited these genes, they have a condition called familial hypercholesterolemia.
All right, now we're getting into familial hypercholesterolemia, which is a very ambiguous term. It's quite, use a lot of amphiboly here. This is an example of exactly that, amphiboly. Familial hypercholesterolemia can refer to two things. Number one, an abnormal cholesterol reading, so abnormal meaning in relation to the normative ranges of the population. The population. We already covered what the population is, because it's not the actual population of people. It's a certain population of people. But it's abnormal in relation to those thresholds. That is thought to be due to genetic factors. Yeah, so that's one. That's one. The other condition actually involves people, I just dealt with this with Dr. Joel Kahn yesterday, involves people that die in the teenage years, actually, the early teen years, if not even before that, due to cellular starvation and oftentimes atherosclerosis, which is a genetic problem with them. It's an actual genetic problem where they cannot sequester excess cholesterol from the bloodstream. In which case, yes, it will start to enter arteries through cytosis because into the tunica intima, because where else is it supposed to go? If you have a hose and it's running and you just right on the top, what's going to happen? So you cannot extrapolate that to normal people.
Hypercholesterolemia, in which they have super high LDL cholesterol levels.
Not cholesterol. And by the way, I just mentioned it. Did you catch that? Rewind. Rewind.
Because their liver is unable to remove the LDL cholesterol from their blood.
Ah, see, there you go. So can that be extrapolated to literally anyone else? The answer is no. Period. Or, if you're in the UK, full stop.
Now, a 4,000-person trial called Prevention of Early Subclinical Atherosclerosis, they looked at young people with no known atherosclerotic cardiovascular disease. The mean age of the study participants, they were 45, and they used super powerful fancy imaging to check out blood vessels all over their body. So if you feel the side of your neck, like right in front of this neck muscle, you'll be able to feel a pulse. That's your carotid artery, the blood vessel that supplies blood to your brain. If you feel your upper thighs near your groin, you'll find the femoral artery. And as medical doctors, we've all had to feel them to place central lines. And when these arteries get blocked, blood flow distal to those arteries suffer. Now everybody's different. Men have more blockage than women. Maybe our estrogen protects us when we're pre-menopausal. LDL cholesterol doesn't correlate well with how much plaque your body has. 45% of people with normal LDL cholesterol still had atherosclerotic cardiovascular disease. The heart vessels, like I said, doesn't get blocked first. So to tell if you have atherosclerosis, you really need imaging of your femoral arteries. Those are in your groin. And the other problem is that the number for
I'm not averse to that idea. Fine.
normal cholesterol keeps changing during the time of that.
Yeah, it keeps changing. Yeah. They also change the threshold. That's a great point, Lou.
Study, LDL cholesterol was defined as 130 milligrams per deciliter. But at that number, 58% of people had atherosclerotic cardiovascular disease. Now,
all right, so basically what you're saying is that LDL is not a strong predictor of atherosclerotic disease or atherosclerosis in the first place, heart disease, coronary heart disease, cardiovascular disease in any form, and in reality, the actual predictor is damage to tissues because physically speaking, again, pertaining to physics, that's literally what you have to have.
45% of people who had LDL cholesterol of 110 milligrams per deciliter also had atherosclerotic cardiovascular disease. And this is why the American Heart Association lowered the normal LDL cholesterol to 100 milligrams per deciliter.
Wow, that's why? Again, not to be too cynical, because it's never a good idea to be too cynical. It doesn't make anyone happy, including, most importantly, yourself. And oftentimes it's just wrong. Never attribute to malice what you can attribute to ignorance. But, oh boy, that's really, yeah. So now what they can say is you've got high cholesterol if it's over 100 in terms of your LDL level. So instead of just admitting, oh, it's just not really a good predictor, is it? They said, oh, well, let's just lower the threshold. Ha ha!
But many influencers believe that that number is just too low and that a
unless it's what your genes encoded for given their circumstances. Fucking
high LDL cholesterol is healthier, despite several studies.
No, it's indicated to have the LDL level whatever it is given the circumstances. What is indicated as well is to eat an indicated diet for your speciation, which is a hypercarnivorous diet once again.
Showing an association with premature cardiac expiration. Now, unfortunately for them and their followers, I don't think that they appreciate the significance of atherosclerosis. In case you have
Well, unfortunately for you, Lou, as well as your followers and viewers, I'm going to say the exact same thing. And you also don't have a grasp on reality, at least enough of one. I'm sorry. Again, I'm rooting for you, but you need to do better.
notice, the vast majority of non-cancerous disease is related to poor blood flow. And this is why as you age,
Related to, so associated with. Okay, and let's say that that's causal. We already covered the salient factors here.
you have more infectious diseases and delayed healing. This is not new.
Well, of course, because you need blood flow for literally all of that. So that's something I'm willing to accept.
Atherosclerosis dates back to over 4,000 years ago. And
Yeah. Nice one bringing up the Egyptian mummies, which was really the first evidence that we have of atherosclerosis occurring. And what did the ancient Egyptians eat? I don't know. Let's look in my book Contrainidicated real quick. Let's actually find out what they ate. The primary diet of ancient Egypt, circa 3150 BC, consisted of bread, fruits, vegetables, honey, olive oil, flaxseed oil, safflower oil, sesame oil, fish, waterfowl, and occasionally red meat that they would boil particularly. Primarily, however, it consisted of grains and boiled meat, with the Egyptians at the upper echelons being the ones who consumed the meat, and the slaves/peasants being the ones that had most of the grains relegated to them. What's interesting about the ancient Egyptians, however, is that they had quite a significant prevalence of arteriosclerosis, heart disease, within their population. This is found when researching their mummified remains, which uncovers arterial scarring and plaque buildup within the vascular system. The ancient Egyptians did not live too long either, which may be in part due to this new change. Other photos of ancient Egyptians also show relatively skinny people with large, bloated, inflated abdomens as well, along with others who were skinny but destitute of any muscle mass, the latter group typically being the slaves who subsisted on grains only.
at the time, people didn't realize that the association between high lipoprotein levels correlated with advancing atherosclerosis.
Now that I've said what I've just said about the ancient Egyptians, do you realize how stupid she sounds? Notice, Lou, that I didn't call you stupid. I'm saying that you sound stupid. And I'm not saying that in a facetious, flippant way. This is sad. It needs to stop. I am rooting for you. Please get a grip. We were all here at one point. We have to remember that. I thought cholesterol and saturated fat was bad for you. I think we all did. All right? We've all been here. But come on. Come on. Wake up.
And this is because science didn't discover lipoproteins until the 20th century. Now, have you ever seen these spots on people's faces?
Yes, xanthelasmas, and in this case, xanthomas, differentiating atherogenic from non-atherogenic. Right. Okay. So they're cholesterol deposits in the skin. So that is very interesting as a phenomenon. And you know what? I'll tell you something right now. Well, first of all, I want to ask, what is the incidence of people eating a carnivorous, high cholesterol diet, bereft of carbohydrates, a more indicated diet, or at least one that best approximates one? And these phenomena. And then whenever you answer that question, then you have to consider, in the people that actually do exhibit those, how much of that is actually due to that diet and how much of that is due to previous behavior. And then finally, is that necessarily representative of pathology occurring? And then same question applied there. If so, is that representative of their past diet or current behaviors now? So there's a lot of things that you have to consider. But the thing that I was actually going to say was I actually know very little about these. We all have limitations when it comes to what we know. And typically what I say is I know very little about X blank whatever yet, because I have a very studious mind, and I want to know like everything as much as I can get my hands on, right? So, um, yeah, but I just want to say that right now. Full disclosure.
Arms, or body. These are called xanthomas, which is a condition in which fats like cholesterol and triglycerides, they build up on the surface of the skin. And oftentimes they will be waxing appearing, kind of yellowish in color. This means that the fats like cholesterol and triglyceride, they're precipitating out of the blood, kind of like.
Right. Okay. So that would probably be a problem. That'd probably be indicative of a problem. However, this puts into question exactly what I said. Is that due to past behaviors? If someone goes from a past poor diet to a that's high with high triglycerides to a carnivore diet, does that mean it's the fault of the carnivore diet if they have that develop, or does it mean it's the fault of their past behaviors? Okay, this is why there's nuance involved here. It's why it's very important. The transitioning process is very, very, very important. Very important.
Like how sand falls out of water. If you have this, you have a hallmark of progressive atherosclerosis.
Do they necessarily have atherosclerosis? And if so, then it can't be because of a high carnivore, like a carnivore diet with high fat and high cholesterol in it, because it takes decades to have developed that. See, that's stuff that I do know.
Now, since you have blood all over your body, you can potentially have these lesions occur anywhere in the skin, but they are most commonly seen over your joints, especially your hands, your tendons, your buttocks, and your feet. But before you get xanthomas, you'll likely have retinal changes that an ophthalmologist can find.
Right. Okay. So yeah, I'd really love to know the incidence of that happening and what demographic of people that actually happens in. Hello. Is that due to cholesterol? Because we already covered this. It's not.
And you'll probably have low back pain and digestion.
Probably, huh? Okay.
Issues and fatigue. The point is, these are all subtle symptoms that happen due to the lack of blood flow. In essence, all of these are signs and symptoms of lipid metabolism problems.
Okay. Well, you can say that, but again, is that due to the consumption of cholesterol and saturated fat? Or is that due to the consumption of high carbohydrate, high fat diets?
And you're either overeating calories
Covered that.
or eating the wrong fat.
Ah, the wrong fat. Good. The wrong fat. Yes, of course, Lou. Of course, we're eating the wrong fat.
And you're creating this cholesterol imbalance, challenging your liver's ability to dispose of blood cholesterol.
All right, I think we're done. I think we know. Oh, you know what? No, what is she doing now?
Hi, friends. I am so thrilled that you want to take charge of your health and take charge of your food. Now, I know nutrition can be complex, but it does.
Nutrition. So she is talking to us about nutrition. Good. Great. I covered that in the beginning too. Nutrition. Yeah. Tell us all about nutrition.
Have to be. And I'm here to support you in this lifelong journey. So if you point your camera app to this QR code, it'll take you to a link for a free handout that I created just for you. And if you like it, if you want to see other handouts, please go to the link in my show notes, and then you can leave me your feedback on what I could do to help you in your journey. Okay, back to the video.
Okay. What's this handout? What does this handout say? Are we critiquing a handout now? Get your Why Your Body Needs Biotin handout. Looking for a easy recipe. Sign up to receive our Why Your Body Needs Biotin handout. By signing up, you'll also receive occasional emails with healthy tips, recipes, and exclusive offers. Don't worry, you can unsubscribe at any time. Biotin, huh? All right. Yeah. No. I think we've watched enough of it. Dr. Lou, I genuinely do mean this. I don't have anything personally against you, but please look deeper into this, because you don't know enough about this. You don't know enough, and it's fine. There's no way to frame this that isn't going to sound patronizing. A lot of times, condescending, patronizing tone is often perceived by the person through projection because they are projecting their perception of their own inferiority to the other person, which is why oftentimes when you explain the reason why someone thinks something to that person, they think it's patronizing. It's not I mean, I want to talk to you like on the same level here. It's fine to not know certain things, okay? But it means that there's a demand for me to tell you what's wrong with all of this. So you don't seem to understand how to interpret science. You have a better grasp of others. That's good. But that's a low bar. All right. This isn't good. This wasn't good. Cholesterol's not the problem. Applebee's not bad. LP little a isn't bad. Triglycerides even themselves aren't necessarily bad. So we need to get that out of the way. All right. Yeah, so now to you directly, my dear viewer. Don't worry about eating cholesterol. Don't worry about eating saturated fat. Okay? Don't worry about eating a carnivore diet. In fact, if you're not on one now, join us. Join us today, slowly, prudently, or else you will regret it, potentially. So, with that being said, if you enjoyed the video, leave a like, subscribe to this cause, because if you haven't already, I'm not sure what you're doing. Leave your thoughts in the comment section below. Also, once again, buy my book, Contrainidicated, if you haven't already, a closer look and revision of mainstream health axioms that have perpetuated illness, disorder, and disease for over a century, if you have not bought that book already. And subscribe to the Patreon as well to gain access to 1 week early uploads, ad-free content, uncensored content, loads of old, very antiquated videos from before I was ever a public figure, loads of Patreon exclusive uploads whenever I was doing that when I became public once a week or something like that. And also an exclusive Discord server for my tier 3 members, if that's something that you're into. And also, once again, there are a lot of morons in the space. There are a lot of people that say things that they think make sense when they don't at all. And a lot of those people actually tend to be coaches. And what I have to say is that in order to be a coach legally, all you have to do is call yourself a coach. I'm serious. If I called myself Coach Eddie Goki right now, at your service, well, that would be completely legal. That would be completely legal. But I want to make authority, as much as appealing to authority is a fallacy, I want to make authority actually mean something, because people are still going to appeal to authority nevertheless. So you might as well make it mean something and actually sign up to be a member of our carnivore certification program, nutrition certification program, as well as exercise and fitness program whenever spots are available again, because, well, we took a total of 10 people, and so now we're waiting for more slots to open. But this will allow you to get international accreditation, international certification as a nutrition coach and fitness coach, as I alluded to earlier in this video, which allows you to, once again, talk to medical professionals like Lou here, as well as getting insurance, because that's important to have no matter what it's for, no matter what it is. So, anyway, yeah, so that's very important. Refer to the links in the description below to either visit our website or to visit, to speak with Coach Peter, who actually runs the program himself. He's been coaching clients for over 20 years, so he definitely knows what he's talking about. So he's now moved to the coaching coaches element of his life. And so refer to those links and tell him how you heard about the program, and then he'll be able to navigate sort of an embarkation route for you. So, that being said, join me next time when we're reacting to more morons on the internet. Not really Lou, I'm not saying she's a moron, but more moronic claims and erroneous claims, fallacious logic, failure to understand statistics, and a failure to understand the distinction between science and scientism. So, till then.